Hello students, welcome to today's object-oriented software engineering class. In this session, we will learn about inheritance and polymorphism, two of the four fundamental principles of object-oriented programming. These concepts enable software reuse, flexibility, and efficient system design. Let us begin with generalization. Generalization represents the relationship between general class called as superclass and more specific class called as subclass. For example, in this diagram, you can see shape is called as general class. The other name of general class is called as parent class, superclass, base class or ancestor class. The other three classes called as square, circle and triangle forms one among the shapes which are called as child class, subclass or descendant class. When we move from top to bottom, we can say it is more specialized relationship, and we move from bottom to top, we can say it as more generalized relationship. Inheritance is a mechanism through which a subclass acquires the complete features and properties of their superclass. A subclass automatically inherits a superclass attributes, operations, relationships and constraints. This allows developers to reuse existing code instead of rewriting common functionalities. One of the most important concepts associated with inheritance is called as method overriding. Suppose, for example, in this picture you can see a class called as shape, which is a superclass, has two subclasses called as square and then circle. There are three attributes inside the shape class: origin, width and height. Similarly, three methods called as draw, get area, get bounding area. Now, the two different classes called as square and circle can inherit all the attributes and all the methods from its superclass. Additionally, a class can even create new attributes called as radius. In this situation, the attribute radius is the property of the circle class and it has not been accessed by square or shape. Signature of all the methods should be same as that of the superclass. That is, the method name, arguments and return type should be same of the superclass and that of the subclass. This picture clearly represents the idea of overriding. In this inheritance relationship, you can see the class shape has three functions called as draw, get area and get bounded area. Similarly, the two other classes called as square and circle inherits two different functions called as draw and get area. But the implementation of the draw and get area will be different for square and the circle class. For example, in square class, the same function called as draw will draw a square with height and width as a parameters. But for circle, it draws a circle by getting radius as a parameter. Similarly, area functions. So such common function name but different working implementation is called as method overriding. Sometimes a superclass cannot provide a meaningful implementation for certain methods. For example, a draw function for the shape class, that is superclass, cannot draw any invalid shape, which is not at all possible. Thus, an operation that lacks an implementation, where implementation method cannot be written for any operation, is called as abstract operation. So in UML, we can write such operation, that is abstract operation, with operation name in italics. A class with one or more abstract operations is called as abstract class, which cannot be instantiated. That is, object cannot be created for such classes. This picture clearly represents the meaning of abstract operations and abstract classes. So the class shape has three functions, namely draw, get area, get bounding area. As we have already discussed, the functions draw and get area cannot be implemented for the class shape. It has to be inherited. That's why the draw and get area are written in italics. These operations are called as abstract operation. You can see the two subclasses square and circle has to inherit the functions called as draw and get area where the implementation code is written. But on the other hand, get bounding area is a function where implementation can be provided. Such functions are called as concrete operations where the implementation is written. So abstract operations are those where implementations are not written. It will be written only in the inheriting subclasses. But concrete operations are those where implementation is already provided. This slide provides the difference between abstract and concrete class. So an operation that is declared without any definition or implementation is called as abstract operation. A class which contains at least one abstract operation is called as abstract class because it must be inherited. On the other hand, an operation that is declared with the definition, that is implementation, is called as concrete operation. A class that inherits abstract class and provides implementation is called as concrete class. Now let us understand polymorphism. The word polymorphism means many forms. It allows same method to perform different actions depending on the object that invokes it. For example, the draw method behaves differently when it is called by circle object or when it is called by square object. So it is called by square object, it draws a square, whereas when it is called by circle object, it draws a circle by obtaining the corresponding parameters. Similarly, get area calculates different formulas for different shapes. In the given example, there is a class called as canvas class, which is called as superclass. This contains multiple shape objects, such as circles and squares. When canvas object invokes a draw function, each object responds according to its own implementation. This makes software flexible, extensible, and easier to maintain because new shapes can be added without modifying the existing code. From placement perspective, inheritance, method overriding, abstract class, and polymorphism are among the most frequently asked questions. You may ask questions such as, what is the difference between inheritance and generalization? What is method overriding? Why do we use abstract classes? How does polymorphism improve software design? These concepts are also widely used in coding assessment, framework development, and system design interviews conducted by leading software companies. So to summarize, in today's session, we have introduced the concept of generalization, class inheritance, method overriding, abstract classes, and polymorphism. Thank you all. See you in the next class.